Okay, so now we've collected our data, or I've collected my data. Here's my little scanned, whoops, sorry, the scan of my notebook page. Now this is, let's see, like one more smaller. There we go. Okay, this should be available on Blackboard, same place you found this video. So here's what I did, I forgot actually to put an objective in. I guess I could call this tennis ball floor CR data, so maybe that's the title, but I didn't really see what I was trying to do, so that's probably a mistake. But I said, I had the tape extended vertically. Here's my crappy little diagram. So this is the tape measure here. This is the vertical part of the tape measure, the actual tape measure, and there's a little, boxy part of the tape measure, I guess you call it. And then the height of the tape measure itself was 3.2 inches. I dropped the ball from height capital H, so it shows it like falling to the ground, and then goes boing and comes back up to a rebound height H. So the analysis, before I did the data, I did the analysis. You don't necessarily have to do it that way. I like to do it, sometimes it's nice because if you do the analysis, then you have a better idea what you should be looking for in the data, and you can, find mistakes faster, but not necessarily required to do it that way. So for the downward fall, I said it falls to this height capital H, and when it hits the ground, it's going to have a speed of u. So we're dropping it from rest up here, right? And then it hits at a speed u. I use u for height, or sorry, for speed or velocity before a collision usually, and then v afterwards over here. But so impact speed is u. We're dropping it from this height capital H, so I use my v final squared, v initial squared plus 2a delta y. So final velocity just before it hits the ground is u squared. 0 is the initial velocity, and then you have 2. Acceleration is negative g. See, I set up y positive going up. So there's negative g acceleration, and then the delta y is negative h because I'm going down, which is negative y by distance h. So there you go. And so then these two things cancel, and what you get is u squared equals 2gh, capital H that is, and then u equals square root of 2g capital H. Okay, similarly over here, you guys can, and you guys have seen this in class, so I probably shouldn't even explain this in detail, but similarly you get final velocity 0 as it rises back up, starts at v to negative gh, blah blah blah, v squared. What you get is v squared equals 2g little h, so v equals square root of 2g little h. So the coefficient of restitution, as you recall as we defined it, is little v over little u. So it's velocity rebound over velocity of the impact. 2g little h over 2g big H, all square rooted, so square root 2g little h over square root 2g big H, and then square root of little h over big H is coefficient of restitution. So that's basically the simplest way to put it. Now I also did this over here where I squared everything, so then I could predict like what the slope of my line should be, and that's okay. But I think what I really want to do, and I wish I'd written it, but what I really want to do is use square root of h equals CR times square root of big H. So take this whole thing and just take the square root of both sides. That's the equation I'm trying to fit, or that's what I'm hoping to see as linear thing. And I'll explain why. It's because I want to have to take the square root to show you guys. So here's my data, and I've entered it here in Excel already. So let's bring this to the foreground. There we go. Okay, so here's my data in Excel. I've got one column for big H in inches, one column for little h in inches. Actually, if I was doing this properly, I'd have like a label saying this is my height data and maybe some other things. But for now, I'm fine. So what I want to do is I actually want to plot square root of big H versus square root of little h. So what I'm going to do is I'm going to make a new column, call that square root big H. I'm just typing in titles here, and square root of little h. Okay, so what I want to do now is I want to actually fill these with values for the square roots of these things. So this is going to be the square root of this column. Now, filling this in Excel, so I showed you guys how you can reference other columns, like for example, or other cells. Like for example, this sets this equal to A3. So see there, and then the copies this value. And then if I change this here, this will change too. But what I really want to do actually is get the square root of A3. And so the way you do that is, if you know what the function name is, that's great. If not, you click on this insert function thing, and once you get there, is you get a little thing. So like here's you can search here, but then also you can just pick one here. So these are some various functions they give you. Category, so I'm going to go for math and trig because I'm looking for square root, which is a math function. And then we got all these things. I'm just going to guess that the square root thing is probably like SQRT or something, but to be sure, we can look down and, oh, look, there it is, SQRT. Now you can either, click and get like a little wizard that'll do stuff. So I double click there, and now I'm getting this. But really, what we can do, I'm just going to cancel. Remember, it was SQRT. So all you do is SQRT parentheses, and then the cell you want to take the square root of. So I want to take A3. So either I can just click A3 now and automatically insert that in, or I can type A3 and then it'll also pick it up. Either way works. So you do that, hit return, and there's the square root of cell A3. And then if I want to fill that down, I just do that, and this takes the square root of A4, A5, A6. So it fills in and automatically, goes to the next one as it goes down the list. And here I want to do the square root of my little h. So this is actually not case sensitive. So I typed it in caps before, but I don't actually need to. So I can do square root of B3, and there you go. And it's also nice, this is one of the features in the newer versions of Excel that highlights the colors of, and so this blue here matches this blue. It's another nifty little thing. And there's the square root of B3, and 9 square root of 9 is in fact 3. So that's all good. That's working fine. So there we go. So here for my data points are, these are the square root of big H and the square root of little h. So now I want to plot these. So the way we do that is we get both columns, we draw a box around them like that. So what I'm doing is just put that, then click and hold the mouse button, drag it out, and then there you go. So now I've got both of these columns selected. I do insert, and on like Excel 2007, this will be a little different. There's like the ribbon thing at the top and all that wacky stuff, but fundamentally it's sort of the same. There's like an insert tab you find, and then there'll be something else. But what I want to do is insert a what do I want to insert? Oh, a chart, right? So a chart is what they call a graph. Okay, pick the chart type. Now you might think it's a line chart or a dot chart or something, but it's actually called a scatter chart, XY. So that means you're giving it the X values and the Y values. Here is what I want. Here's the points. You can do this and it'll connect with smooth lines, and this it'll connect with straight lines, and here it does the lines without one of the points. But what we really want to see though are just a scatter plot of our points. And sort of press and hold to view samples, so I can do that and see there's my sample graph. Okay, so next, what's next? And then you can fill in all kinds of crap here. This is the data range. If you're really like a wizard, you can adjust this, but you don't need to screw with that. And series, and you can adjust that too if you want. Next, and then you get to put like titles and stuff on it, and you can adjust this stuff later. But I'm just going to say, so fine. H versus H, so little h versus big H. And the x-axis is our independent variable, so that's big H, and I'm going to say in inches, and little h in inches. And of course you can't do like exponents or anything in here, at least not easily. Maybe you can, I don't know, but I don't know how to do it. So if you're ever doing like inches squared, or like when you have to do like t squared, then you might just have to do like t up arrow 2 and sort of, and then it'll actually print in the t up arrow 2. Like see here, you can see a little bit this t up arrow 2, or caret. Why do I call it up arrow? Anyway, t caret 2 for like the t squared, and it'll come out like that. And it's not like pretty. If you're going to publish this like someplace respectable, then you might want to go to the time and effort to figure out how to actually get a t squared in there. I don't know, but somehow you can do it probably. So if you're going to publish this someplace and make it pretty, then you can do that. But for for a report you're turning it to me, I don't care. I know what t caret 2 means, so that's all good. So we'll leave that alone. So that'll be good. Axes, this is all good basically. Grid lines, unless you want to have, well, this is like major and minor grid lines. So we can do like major. If you want to turn on grid lines vertically, horizontally, whatever. Tons of grid lines, no grid lines. Whatever. Do what you want with that. Legend, that's just where the legend gets put, so it'll out. And actually, screw the legend. I don't care about this for now. So and then data labels, if you do that, it'll put like the X positions and the Y position next to everything, which can be nice, can be annoying. So it's sort of you got to play that by ear, depending on what makes it look good and makes it most informative. So finally, I'm going to hit finish, and there Yikes, that is ugly. Okay, so I think if I grab this and make this bigger, it should, yeah, there we go. So it'll auto scale a bit. So now I've got, I got something decent looking. I've got like, here's my big H of, oh, whoops, you know what? I gave the wrong, I put the wrong axis titles, because this is actually square root of little h, and this is square root of big H. So let's see, how do I do that? So actually, so I can actually just like type in here. Oh, that's cool. So you can click on the legend, you can actually edit it. And maybe there's some way to even get exponents in there, or superscripts and subscripts. I don't know. But anyway, and then how do I write square root of inches? I guess I can do a square root of inches. That's really ugly looking. I'll say for this you should follow the same rule as for most stuff, which is it's okay to turn in stuff to me like that. I don't care, but man, if you ever are doing this with like to really publish, then try to improve it. Okay, so here's my 4 data points, and so I can sort of click and like select that data set here, and it actually shows me where it came from. So that's kind of nice. And what I want to do actually is add a regression, or do a linear regression. So the way you do that in Excel, right click. Here's your options. You get add trend line. That's what they call it. They call it trend line because these are all like business peoples who don't understand. If you use the word linear regression in front of most people who use Excel, they'd be like, what the hell is that? So I just do that. Series 1 is fine. Options. So let's see. You can give it a name, but you're not going to print the name, so who cares? Forecast. No, that's like some weird stuff. Now, let's see. First, we want to display equation on a chart because that tells us what the slope is. And set intercept. I'm going to leave that off for a moment, but we can fiddle with that in a minute. And then finally, display r-squared value on the chart. Now that's a note about how that's about how well it fits the line. For my money, if you understand how r-squared is calculated and what it means numerically, great, go ahead. I say just look at the thing and see how linear it is, how well it fits the line. So I'm going to go ahead and go with this. So there we go. I'm going to move that a little. So here's our linear regression. It's kind of it's okay. That's not bad. So that's sort of basically how to do stuff. Now, as far as like handling data and trying to figure out what belongs and what doesn't and other stuff like that, I'm going to explain that in the next video because this one's about to reach the limit. So back with you in a moment.